This video is meant to talk through pages 6 and 7 of lesson 9. So here we have more practice determining endothermic or exothermic. So in the spaces below, you'll be asked to draw atom models for both reactants and products in chemical reaction. You're then going to count the number of bonds broken, count the number of bonds made, and from those numbers, you should be able to determine if the reaction is endothermic or exothermic. How do I do that? That information is given to you in this second paragraph here. More bonds broken than formed correlates with endothermic. More bonds formed than broken correlates with exothermic, okay? So you'll come down here and you'll draw these out. Now, you might be asking, how do I know what sodium bicarbonate looks like? Well, you can copy and paste and look in Google, okay? So you're going to look in Google Images and you'll notice here we have sodium bicarbonate and then you can start drawing. Okay, so as you start drawing this, you might realize that it's really kind of hard to draw these in this program. Whoops, undo. You want to make sure you have lines in between everything. You'll notice that this is a little bit tricky. If you feel like this is too tricky for you to draw, just use the text and write, I will email you a picture, and then actually email us a picture, okay? So if you want to do this on a sheet of paper instead of doing this in this program, that's fine. Just for simplicity purposes, if we go down here, I have already drawn out this below. So I just kind of want to walk through how you're going to manipulate what you've drawn into figuring out if it's endo or exo. Okay, so we want to figure out what is being broken, what is being formed. So for broken, I'm going to use red. So on this side, we have two oxygens that are double bonded together. So these two oxygens, that means they need to break up. Also over here, we have a hydrogen connected to two oxygens, but then it's like this one would be connected to that one. So we need to break this bond and we need to break one other bond. Whoops. Actually, wait, I'm going to undo that one. Whoops. Break this one and this one. Okay. Just because these two are going to stay together and then come over and form this. All right, so then bonds formed. So bonds formed, we have this one being formed, we have this one being formed, and we have now a double bond here instead of a single bond. Okay, so you'll notice we have 3 bonds being broken, and we have 3 bonds being formed. And this goes against what we were talking about, right? So you'll notice as you're coming through these, you're going to see some that do not match up with what we were saying earlier. So after you get through all these examples, this is where we go here to page 7 and we watch this. So the answer to this is not all bonds have the same amount of energy. Some are stronger, some are weaker. And this video chats through all of that.